splicing the secondary feed from a transformer in a junction box to feed two separate panels, with each panel having a main circuit breaker, results in several National Electrical Code or NEC violations. Firstly, NEC Section 450.3b mandates that transformers must be installed in a vault, on a pole, or within a metal enclosure. The installation of a transformer within a junction box does not meet these requirements, as junction boxes are not recognized as acceptable enclosures for transformers under this code section. The primary purpose of this code is to ensure adequate protection and containment of the transformer to prevent electrical hazards and ensure proper heat dissipation. Secondly, NEC Section 450.4 dictates that the primary and secondary conductors of a transformer must be protected from coming into contact with each other by using a barrier or a similar protective method. The use of a junction box does not provide the necessary level of protection to prevent accidental contact between these conductors. The inadequate separation increases the risk of short circuits and other electrical faults. Thirdly, NEC Section 110.14c stipulates that all splices must be made within a junction box or another approved enclosure. However, it is crucial to note that junction boxes are not approved for splicing the secondary conductors of a transformer, especially when feeding multiple panels. This is because the high current and voltage levels involved require specialized terminations and protection that a standard junction box cannot provide. Improper splicing can lead to overheating, loose connections, and potential fire hazards. Fourthly, NEC Section 408.3 specifies that panel boards must be installed within a cabinet or enclosure that is specifically designed for that purpose. A junction box does not meet this criterion. Panel boards require secure mounting, proper labeling, and sufficient space for conductor termination and routing. Using a junction box compromises these requirements and can result in an unsafe installation. Fifthly, NEC Section 408.3b mandates that panel boards must be mounted in a vertical position. Junction boxes are not designed to facilitate this type of mounting. Vertical mounting is essential for proper cooling and to prevent stress on the panel board components. Failure to mount panel boards vertically can lead to overheating, reduced lifespan, and potential equipment failure. In summary, splicing a transformer secondary feed in a junction box to feed multiple panels with main breakers introduces several serious electrical code violations. These violations cover transformer enclosure, conductor protection, splicing methods, and panel board installation requirements. Adhering to the NEC guidelines ensures a safe and reliable electrical system. For transformer installations, always verify that the transformer is housed in an approved enclosure, such as a vault, pole-mounted structure, or metal enclosure designed for transformers. Ensure adequate physical separation and insulation between primary and secondary conductors. Use approved methods and connectors for splicing conductors. The junction box is not an acceptable enclosure for these kinds of connections. Always install panel boards in cabinets or enclosures specifically designed for panel boards or mount them vertically as per NEC requirements. This ensures that all electrical components are adequately protected and that the system operates safely and efficiently. When installing transformers, consider the location and environment to select the appropriate enclosure. Vaults are typically used for indoor installations where space is limited and fire protection is a concern. Pole-mounted transformers are suitable for outdoor applications where they can be isolated from pedestrian traffic. Metal enclosures are a versatile option for both indoor and outdoor installations, providing protection against environmental factors and physical damage. For conductor protection, use barriers, insulation, and spacing to prevent accidental contact between primary and secondary conductors. This is particularly important in high-voltage systems where even momentary contact can result in severe electrical faults. Ensure that all splices are made using connectors and methods approved for the specific type of conductor and application. High-current connections require specialized connectors that can withstand the heat and mechanical stress associated with heavy loads. Always follow the manufacturer's instructions and use the correct tools for making splices. For panel board installations, use cabinets or enclosures that provide adequate space for conductors, circuit breakers, and other components. Ensure that the enclosure is properly grounded and bonded to prevent electrical shock hazards. Mount panel boards vertically to promote natural convection cooling and prevent overheating. Label all circuits clearly and accurately to facilitate troubleshooting and maintenance. Consider the load requirements when selecting the appropriate size and type of panel board. Overloaded panel boards can overheat and fail, leading to power outages and potential fire hazards. Regularly inspect electrical systems to identify and correct any code violations or safety hazards. This includes checking for loose connections, damaged conductors, and overloaded circuits. By adhering to NEC guidelines and best practices, electrical systems can be designed and installed to operate safely and reliably, minimizing the risk of electrical accidents and equipment failures. The NEC provides specific guidelines for transformer installations, including requirements for ventilation, clearances, and grounding. These guidelines are designed to prevent overheating, electrical shock, and other hazards. The NEC also specifies requirements for overcurrent protection, which are essential for preventing damage to transformers and other electrical equipment. Overcurrent protection devices, such as fuses and circuit breakers, must be sized appropriately to protect the transformer from overload and short-circuit conditions. Proper grounding is essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. The NEC provides detailed requirements for grounding transformers, panel boards, and other electrical components. These requirements are designed to create a low impedance path for fault currents, allowing overcurrent protection devices to quickly clear faults and prevent electrical shock. Additionally, the NEC includes requirements for arc flash protection, which are designed to protect workers from the hazards of arc flash events. Arc flash events can occur when there is a fault in an electrical system, resulting in a sudden release of energy in the form of heat and light. Arc flash protection measures include the use of personal protective equipment, such as arc-rated clothing and face shields, as well as the implementation of engineering controls such as arc flash relays and current limiting devices. When installing electrical systems, it is essential to consult the NEC and other applicable codes and standards to ensure compliance. Local electrical inspectors can provide guidance and assistance in interpreting and applying these codes. Additionally, it is important to use qualified and experienced electricians for all electrical work. Qualified electricians have the knowledge and skills necessary to install electrical systems safely and correctly, minimizing the risk of electrical accidents and equipment failures. Proper planning and design are essential for ensuring the safe and reliable operation of electrical systems. This includes conducting load calculations to determine the appropriate size of conductors, transformers, and other equipment. It also includes selecting the appropriate type of wiring method and ensuring that all equipment is properly rated for the intended application. Regular maintenance is essential for keeping electrical systems in good working order. This includes inspecting electrical equipment for signs of wear and tear, tightening loose connections, and cleaning electrical panels and enclosures. Regular maintenance can help prevent electrical accidents and equipment failures, extending the lifespan of electrical systems and reducing the risk of costly repairs. In addition to the specific NEC sections mentioned, other related sections may also be relevant depending on the specific circumstances of the installation. These may include sections related to wiring methods, grounding, overcurrent protection, and equipment labeling. It is important to consult the entire NEC and other applicable codes and standards to ensure that all requirements are met. The NEC is a comprehensive set of rules and guidelines that are designed to protect people and property from electrical hazards. By adhering to the NEC, electrical systems can be designed and installed to operate safely and reliably, minimizing the risk of electrical accidents and equipment failures. Always consult with a qualified electrician or electrical engineer for assistance with electrical installations and repairs. These professionals have the knowledge and expertise necessary to ensure that electrical systems are installed and maintained in accordance with all applicable codes and standards.